Welcome back to my YouTube channel all about VLSI. In this particular video, we are going to start with a discussion of barrel shifter. Now, this is a continuation of Verilog Project Development Series where in our previous sessions we have started with carry save adder, SRAM controller and clock gating based FSM we have seen and we have implemented those particular codes in Verilog, and if you haven't watched those particular sessions, I recommend you to once go through them if you want. And coming to this particular session, we are going to look into some other kind of project, which is basically barrel shifter, and it's a high speed combinational circuit, and it is used for shifting the data towards left or right, or rotating the data towards left or right, and performing arithmetic shifts by any number of bit positions. And the specialty of this barrel shifter is it is done in a single clock cycle. You are going to shift or you're going to rotate the data in a single clock cycle. If you're going to use registers, you are going to take multiple clock cycles for performing the shift operation. But using this particular barrel shifter, you're going to rotate the data in a single clock cycle. And barrel shifter is basically a smart multiplexer network that requires reroute that basically reroutes the wires, and no sequential movement occurs, and bits are directly connected to the destination. Now, why barrel shifter is very fast? Because it is purely combinational and no repeated clocking, and delay depends upon only multiplexer depth and the number of stages. That's the reason this particular barrel shifter is very fast. But there are some disadvantages also. Like for larger widths, your multiplexer stages exist and it will be larger combinational paths, and that increases the propagation delay. Now, what I am speaking about multiplexer and all, first of all, let's see this particular diagram and architecture, and let's we can able to understand what are the disadvantages and why we are using a multiplexer and all. For example, let's say if I'm going to have a 4-bit number, let's say the 4-bit number is 0001. Okay. Now let's say this is W3, W2, W1, and W0. And let's say if I'm going to perform shifting operation by 1-bit position, shifting by 1 bit, and exactly shifting in the sense I'm basically and also I'm performing right shift operation. Now when I'm going to perform this right shifting operation, I'm going to not discard this bit, I'm going to rotate this bit to the MSB position. What I mean by this is 0001, and here if I'm going to perform right shifting, this bit will be shifted toward right, 0, 0, and this bit will be rotated to the MSB position like this. So this is what barrel shifter is going to do. Okay, and if you carefully observe over here, this is W3, W2, W1, and W0. And let's say this is output Y, and where Y3 is equal to W0. Y3 is equal to W0, and Y2 is equal to, what is that we are going to have? W3, and y1 is equal to w2, and y0 is equal to w1. These are the outputs which we are going to have. Okay. Now let's say if I'm going to perform the shift operation, this is only by 1-bit position. Let's say if I'm going to do for 2 times, then what is that I'm going to have? This is my number 0001, and let's say this is w3, w2, w1, w0. And if I'm going to perform the shifting for once, this is y, which is equal to 1000. This is for first time I'm going to perform. Now, if I'm going to perform for the second time, then what will be my y value? Y value will be equal to, this 0 will be given over here, 0. This is nothing but my, okay, let me write down over here. This is my W0, this is my W3, this is my W2, and this is my W1. Now this W1 will be given over here. So Y3 is equal to W3, and this will be shifted over here. This is 0, which is 1, which is nothing but Y2 is equal to W0, and this will be shifted over here, which is nothing but Y1 will be equal to W3, and this will be shifted over here, which is nothing but y0 equal to w2. So these are the final positions which I'm going to have if I'm going to perform the shifting for second time. Now let's say if I'm going to perform the shifting for third time, then what is that I'm going to have? 0001, and if I'm, this is my w3, w2, w1, w0. And if I'm going to perform the shifting for first time, I'm going to have 1000. This is the shifting for first time which I'm going to perform. And the bit positions over here is W0, W3, W2, and W1. And if I'm going to perform the shifting for second time, then we have already seen what is the result which I'm going to get, which is nothing but 0100. 0100, and the positions over here is W3, W3, I mean not W3 exactly, W1, sorry, W1, W0, W1, W0, W3, W2, W3 and W2. This is what I'm going to have if I'm going to shift for the second time. Now, if I'm going to perform the shifting for third time, then what I'm going to have, this we already know. I want to give some conclusions from here. That's the reason I'm explaining it. So I'm going to have 0, which is nothing but W2. So Y3 will be equal to W2. And over here, this will be shifted. So Y2 will be equal to W1. And this will be shifted. And this Y1 will be equal to W0. And this will be shifted over here. That is nothing but Y0 is equal to W3. So from all this particular heavy conclusions, discussions, what we can conclude over here is there is a very good conclusion over here. Let's try to understand. So you can see this particular diagram where we are going to have four multiplexers, 1, 2, 3, and 4, right? Now, these are my select lines which are given to all the particular multiplexers. And these are my outputs Y3, Y2, Y1, and Y0. Now, if you carefully observe, if my select lines S1 and S0 is equal to 0, 0, then there is no shifting. This is basically a mode where there is no shifting, and you're going to provide the inputs to the multiplexer. Provide inputs to the multiplexer. This is the case which way I'm going to have if my S1 and S0 are equal to 0, 0. Now, let's say if my S1 and S0 is equal to 1, that means this pin will be selected. For every multiplexer, the second pin will be selected. And if you carefully observe, if I'm going to have S1, S0 is equal to 0, 1, then I'm going to perform right shifting by 1 bit position. I'm going to perform right shifting by 1 bit position. Now, if I'm going to perform right shift by 1 bit position, that is for the very first time, I can see clearly that my Y3 is W0. This is my Y3 is W0. Y2 is W3. Y1 is W2. And Y0 is W1, right? So what should we connect this MSB1? So that should be connected to my W0. See here, we have connected a connection directly from W0 to the first pin. If my select line is equal to 0, I'm connecting to my W0. And coming to my and that is my Y2. What is my Y2 value? It is connected to W3. See here, where is this Y2? Here we are going to get Y2, and this pin is directly connected to W3. This pin is connected to W3. That is what now. Next Y1. Y1 is this one. And we are going to connect this pin. Where should we connect this pin? We should connect this pin to Y0. So where is this Y0? Y0, sorry, W1 we need to connect. So where it is, we are connecting it to, so Y0 is connected to W1. This pin is connected to my W1. You can see over here. So this is how we are going to make the connections by referring to this particular table. Okay. This is for only first shifting. That is my select S1 S0 is equal to 0, 1. Let's say if my S1 S0 S0 is equal to 1, 0. If S1 S0 is equal to 1, 0, that is my second pin. So S1 S0, if it is equal to 1, 0, I need to see which to which particular input my second pin should be connected. Coming to my Y3. So Y3 over here, it is connected to W1. So that's the reason I'm going directly and connecting it to my W1 over here. You can see that I've connected it to my W1. And Y2 it is connected to W0. So Y2 this is connected to my W0. See over here, it is connected to W0. Next, Y1 is connected to W3. Y1 second pin is connected to my W3. Where is W3? Which is connected over here. See, W3. Okay. And coming to my Y0 is connected to W2. Y0 is this pin. This particular input is connected to my W2. It is connected to this W2. So like this, I'm going to make my connection. And coming to S1, S0 is equal to 1, 1. That is my third shifting. And this pin, accordingly, it is connected to my W2 or whatever the pins which we have got. So Y3 is connected to W2. That's the reason this pin is connected to W2. So that is how this one. So that is how we are going to design our multiplexer circuit in such a way that if you carefully observe over here, let's say suppose if I want to perform shifting by two positions, then these connections are already made, right? So immediately the shifting will be happening in a single clock cycle. The shifting by two or shift by three will be happening at the single clock cycle. This is how the barrel shifter is being designed, and this is the reason the barrel shifter is very very fast, and it can be used in your arithmetic logic units for shifting operation or DSP units for performing shifting operations, and this is the reason we are going to use it. So that is how we have designed our barrel shifter. Now, let's say if I want to design, give me a second. Let's say if I want to design, now if I want to write down the Verilog code for this shifting operation, how I am going to write down? Simple. We can simply use this. Let me show you this code. Barrel shifter. We have took a particular module which is barrel shifter. Input is 4-bit W and select line is 2-bit, and this is my output 4-bit. Now within an always block, depending upon my select, if it is equal to 0, 0, you are not going to perform any shifting. But if it is equal to 0, 1, our Y value is equal to W of 0 concatenated with W of 3 down to 1. Why are we writing this? You can see over here. So this is the first time shifting, and this is my value Y. So this is my value Y, which is nothing but concatenated of the bits W0, comma, W of 3 down to 1. That is the reason I've written the code W of 0, comma, W of 3 down to 1. Now if I'm going to perform the rotation operation by 2 bits, then you can see over here it is nothing but concatenation of W1, comma, W of 0, 3 and 2. So you can see over here it is W of 3 down to 1. Okay, and this is nothing but my second time. And let's say if I'm going to perform the shifting operation for third time, then I'm going to write down W of 2 down to 0, comma, W of 3. So W of 2 down to 0, comma, W of 3, which I've written over. So this is how I'm going to perform the shifting operation, and this is how I'm going to write down my code. So let's say if I'm going to give the input as 0001, if I'm going to give the input as 0001, let's check what is our output which I'm going to get for all the particular test cases. And this is my test bench which I've written, where I've written the inputs as reg and outputs as wire, and I've instantiated my design, and here I've given my input and select line, and I've given the display statements and all. And for I've given all the particular cases like select is equal to 0001, 10, and 11. And let me run this particular code. So you can see over here we have, let me run this code 0001. I've given the input. Let's check what is the outputs we are going to get over here. So this is my input which I've given, and this is my select line 0. And I can check my output. Here I'm getting 8. 8 is nothing but 1300. This is what we are getting now for first shift. And next we are going to get a 0100, and next is 0010. So this is how we are going to perform the shift operation. Now let's say if I'm directly giving the select line as uh, let's say if I'm going to directly give the select line as 1, let's see how many cycles it is going to get the shift operation to be done. So let's give the select line directly as 1 1. Let me comment the remaining select lines, and I'm directly giving the select line as 1 1. So you can see I'm directly giving the select line as 1 1. Let me save it and let me relaunch it. See, within one cycle, the shifting is happening for the 3 times, and it is giving the result as 0010. So this is how we are going to design a barrel shifter, and this is how we are going to write down a Verilog code and test it. So yes, so that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.